All right, let's get started. Got some water. So hello, everyone. My name is Miles Schofield from AOPEN. Thanks for joining today. This webinar will be about 45 minutes. I'm going to talk for about 30 minutes. Feel free to send me any quick questions that you have during the presentation. Presentation is going to be just around 30 minutes, a few minutes for questions at the end, pretty typical. So without further ado, let's get started on what we're talking about today. So what we're going to be covering today is a new product that AOPEN America is releasing called the Heat Finder. And what the Heat Finder is, it's three primary things. Number one is a thermal camera, right? And when we talk about thermal cameras, number one thing that you want to note is, of course, accuracy. So this thermal camera is 0.5C between 35 and 42, which is ideal for measuring, in this case, human body temperatures. And we'll talk about how that technology actually works, how it's implemented, and ways you can improve your accuracy in the field. And of course, the other really extremely important thing about thermal cameras is that they're fast, right? There are many slow applications of thermal cameras, but when you're trying to measure fever, fever detection particularly, you want them to be extremely fast because people are going to be standing in lines. And I'm sure you've seen shots of people queuing in lines to go through security and thermal check stations. And of course, the other thing is that thermal cameras are still extremely expensive. And one of the main reasons why we're releasing this product in the United States is because it's one of the market leaders in terms of affordability and features. And of course, I'm going to highlight that throughout this presentation. So this product, first and foremost, is a thermal camera. The second mode is that it is a dual mode IP camera. So if you're familiar with how IP cameras are set up, implemented, et cetera, you should be familiar with this technology. So it works like a typical IP security camera. You can set it up, attach it to your network, assign it a static IP, non-routable, and then you can find it using a DVR, right? So if you're familiar with these type of IP camera systems, that's what this product is. The last thing is, of course, the DVR software and management software. So there's two pieces, T-Guard and Fusion, and this really completes the package, right? So Fusion is just the configuration tool that's on the camera itself, and T-Guard is really the application with the massive amounts of configuration. There's a lot of settings and features in the T-Guard software, everything from logs to tracking to user control, all that stuff. So this product as a whole are these three things put together, and it really is a complete system. You could go take this and install it tomorrow in a school if you wanted to. So this is an out-of-the-box solution, and we'll talk about not only out-of-box solutions, but also other types of solutions that are on the market that people are developing as well. So let's get started. So what are thermal cameras used for in the field? So thermal cameras typically have low volume niche sort of use cases. Of course, the main one we're talking about today is fever detection or epidemic prevention, but they're also commonly used for industrial safety warnings, fire warnings, healthcare, security, because of course they can track people at night. They're far less effective at that than night vision cameras in a lot of cases. Leakage monitoring, and of course product inspection is extremely common. So you can see how in each one of these sort of scenarios, the amount of frame rate, the amount of data you would need, the amount of tracking would be different in all these cases, right? So, but in all these cases, there's not a huge volume of cameras installed, which is why the technologies remained relatively expensive. The other main one that you see that I knew of in the States for years and years was, of course, building monitoring. So smart building technology, you can get engineers to show up and scan your building with thermal technology and help you improve the energy efficiency of your building. That was a huge trend about 10 years ago, I believe. So let's talk about the main use case we're here for today, which of course is fever detection. So when we have a thermal camera system, what is really the goal of the fever detection use case? And we have to take a few points. The first one, of course, is that we're trying to detect your forehead. Why? Because the forehead is an accurate representation of your temperature, right? This is proven. This is how medical thermometers work, and this is what these systems try to achieve, right? However, these systems are not medical devices for a number of reasons. There are like 1 or 2 thermal cameras that do have FDA approval, but you would never use these type of systems to from a medical perspective, accurately measure someone's temperature, right? Because the forehead scanners, the contact, the non-contact ones are just so much more accurate. And when you use these type of systems, they're not designed to be a catch-all. The first comments I always see when you see these type of solutions in the American market is, number one, you know, well, it doesn't catch people who are asymptomatic. Yeah, of course not, right? There's no way, except for mass testing, to catch people who are asymptomatic. And so this is really, you have to think about it not as a catch-all, but as a layer of security, effectively, something that will help control the problem, right? And when you see these type of solutions set up, there's always a secondary action, right? Even if it's a passive system that you walk by, there's always a second action where someone flags the system, they're going to use an actual thermometer on them to confirm, right? These systems are never, ever perfect, so you always want to confirm using a more accurate device. So that's what we're trying to do with this type of system. Okay, so in the APAC market, where these solutions are extremely common, right, they're primarily deployed at airports, schools, businesses, and the market is really high-end, right? And as I mentioned, there's just not enough volume for this particular type of technology to really drive the price down. And that was the goal of this product, was to try and drive the price down and provide more accessibility to this type of technology. Will the price ever be driven down enough? The main issue is really one of the key pieces of a thermal camera is not the CCD, but it's actually the lens. It needs to be made out of indium gallium arsenide, which is not a commonly used material. The only other place it's used in is in logic chips, specifically for space shuttles, right? Normally you would make those out of silicon, but if you put a satellite in the air and you have a processor in it, it needs to be made out of IGA to resist cosmic radiation. So not a whole lot of very important use cases, but not a whole lot of super common one. It's never used in your cell phone or anything like that. So that's sort of the reason why the price of these thermal cameras has remained high for so long. So due to the events of this year, the US market is really starting to become interested in these type of products. Amazon has just deployed you know, millions and millions and millions of dollars at their of these exact thermal cameras, or exact type of thermal systems at their warehouses to scan for fevers, right? I just took some snippets from some news articles. You can't get through into an Amazon warehouse without passing the heat-seeking eye. Spent 10 million. I saw another news article say 15 million. And of course, what Amazon does, people are going to follow suit because they're one of the leading businesses in the United States. And you know, Tyson's looking at it, Intel's looking at it. And you can see that, you know, just as I just pointed out, airports in Asia after the SARS epidemic in 2003 cost between $5,000 and $20,000 or even more in New Taiwan dollars. So, you know, this is just a representation of the fact that these types of solutions are becoming more important in the US market. You know, these large businesses are considering them and spending real money to implement them. So what is our product? So the Heat Finder, like I said, is a dual IP camera system, but primarily it's a thermal camera with backing software. And so the main reasons why we brought this product to the United States is because this one's proven, right? It was introduced to be a price leader in the Taiwan market. It's been installed over at 1,000 sites in Taiwan, which was had one of the best performances in terms of the recent pandemic response. I think they only had 7 deaths for the entire population of 25 million. So this obviously wasn't the only solution that Taiwan used, but it's once again, it's all these things layered together that really helps. So, and this product comes from a reputable source. It's actually was designed by an Acer Select team. It's manufactured by ADE. So all these factors, price, performance, features, you know, that's the main reason why we wanted to bring this product over. We didn't want to try and cobble something together that's never been tested or used before. We really wanted to bring something in that we knew had a pedigree. Okay, so let's try and understand the technology. This is not a tech talk, but let's try and understand the technology so that we understand the difference between all these systems, because they do work in drastically different ways. So the main feature of how a thermal camera works is that it's more like a regular camera than how you would typically experience heat as a human. So the way that we experience heat, right, let's take a fire, is that, you know, when we're really close to it, it's hot, we may get burned, and we move a few feet away, it's warm, and then we move 6 or 7 feet away, and you can't really feel it anymore. It's actually cool. However, when it comes to light, if you have your TV and you walk 6 feet away, you're still fine. And then you walk 20 feet away, you know, no one when they're 20 feet away from their TV says, hey, I need to turn the brightness up, right? That would be the equivalent effect. So what we're really talking about in terms of how to get an accurate measurement out of these systems, you have to think about it like you're taking a picture. Well, what's gonna mess up a picture? A normal camera, well, it's if you're backlit, if you have other lamps and bad lighting. Same exact thing you have to think about when you're measuring, when you're doing thermal scans. What's going to mess it up? Well, if you have a fire in the background or tons of lamps and things like that. So these are the types of things that we got to consider when we're trying to get a really accurate system that's going to help people. Okay, so these are the main technical things you want to consider when evaluating a thermal camera system. Most important one is, of course, when you're doing any measurement is in terms of accuracy. In this particular sense, for a thermal scene, there's a thing called IFOV, which is instantaneous field of view. So what IFOV basically is if you take a single pixel and extrapolate it out to X distance, how big is it, right? And when we're talking about digital measurement systems based off of CCD technology, there are things that, systems that are very accurate in sub-pixel analysis, but generally speaking, when it comes to thermal cameras, you want to measure more than 1 pixel. So for this particular system, the AOPEN Heat Finder, at 2 meters, 1 pixel is 22 millimeters, and a 3x3 sort of circle or grid would be 66.7 millimeters. And as I mentioned, what are we trying to do? Find people's foreheads. And you know, unless you're like me, I got all my hair cut off, right? You're not going to have a 66 millimeter forehead. So for this particular system, you want to be within 2 meters or 6 feet, which isn't a huge distance, but you got to walk by relatively close to the camera. So let's talk about other points. Of course, ambient stability, right? So when you have these type of cameras, they're very referential. Like, just one of the things that can mess you up in terms of measurement is if you have wind or it parked in front of an air conditioner and things like that. So these cameras have to compensate for a whole bunch of atmospheric effects that can affect the measurement. Target stability, right? Obviously, if you go to the doctors or try and use a forehead scanner when you have a whole bunch of thermal anomalies, such as you're sweating, you have a ton of water on your head, you have anything blocking it like a hat, obviously these are not going to help your measurement. Target knowledge. So if you've looked in these systems before, the way that things are related to the temperature, the amount of thermal light that they produce is different from material to material. So what that basically means is that if I point a thermal camera at someone's forehead versus a piece of ceramic, right, although they may read the same temperature, they may not actually be the same temperature. Right. So what's important when you're setting up a system is that the system is actually designed to look at what you're actually planned to look at. Right. So that's target knowledge. And of course, this one, thermal frame rate. In this particular, we want people to go through the system as fast as possible. Thermal frame rate is how many measurements you're getting per second. Not only do you want your measurement to be accurate, but you want a lot of them. That way you can throw out the bad ones. And so when we talk about thermal frame rate, the AOPEN Heat Finder is at 7 measurements a second. Not only that, it can do 7 measurements a second on multiple detection points at the same time. So as people go through in a line, it has no problem seeing 3, 4 heads at the same time as people walk by at 7 measurements a second on 3 people. The last thing, of course, is that you want software that can mask out and eliminate potential errors. So when you're setting up the system, the ideal scenario is that obviously people are standing in front of a blank wall that's thermally stable, no lamps, no fires going on in the background, et cetera, et cetera. But you can see this picture of me with great posture, and I've got some computers running in the background, and so this is a picture of the T-Guard software. You just go in there, something's in the background, you can sort of mask it out if it's going to become an issue. Because you have to remember that thermal cameras themselves, they don't have any recognition or AI technology in them. So it can't tell the difference between your forehead and the heat in the background. So you have to use sort of like a strategic masking technique to get the best measurements. Okay, so that's all you need to know about these systems. So I'm sure you've seen these a lot in the news too. So these are sort of the quick and dirty, like how do we implement this system as fast as possible? It's basically you have a thermal bouncer, right? It's a guy, he stands outside your club or your restaurant, and he just uses a thermal forehead scanner. Which is great, right? It's very accurate, and these are medical devices. They're not too expensive, and they're about 5 seconds a person, right? Great solution, but the 5 seconds per person, when you have a school or a building with 3,000 people working in there in the morning, I mean, that's wasting tons and tons of time. There's queuing and things like that, which is, like I said, exactly why we wanted to focus on a quicker solution at first, right? So the Heat Finder solution is really about speed, and not queuing, and trying to give you value over a thermal bouncer effectively, right? So what are the primary things? All the things I've been talking about. Measures temperature as people walk by. What I like to say, non-invasive, non-intrusive, right? If I'm in America, I'm going back to work right now, going back into my office, I want to feel like the company's done something safe and protected me in some way, but I don't want to stand in line just to get into the office. So this can be set up at any enterprise front desk as people come in. It can be set up, pointing at people as they badge in, et cetera, et cetera. So this is really designed so that people don't notice it. There are a lot of systems where, it shows your face, and people want to see what they look like in IR and all this stuff. But the main reason why we went with this solution is because, we don't want people to think about it. Get back to work, get back to school, and just go on with your daily lives. If there's an issue, you just pop them out of line, scan them really quick, no big deal, right? And like I said, the other primary advantages of this system comes from the software. You have temperature, mask features, access control, et cetera, and of course the multiple continuous detection obviously is for when the line is filtering through as well. So another thing to quickly note is that this particular photo that I'm using here, if you're not used to, there are 2 primary coloring modes for infrared or thermal imaging. The main one is rainbow, but this one's called iron black. So it's just a different type of portraying the information. All right, so like I said, we went with a fast solution for the Heat Finder, the Heat Finder system, but we do, of course, AOPEN is a hardware provider, and we work with lots of solution providers in the United States. And this is a really big consideration as you develop what type of solution is worth the walk versus stand, right? So we already know that a fine solution is the thermal bouncer that takes about 5 seconds per person. So what could you add to these systems? And a lot of our partners are looking at these systems, right? Especially on an AOPEN all-in-one ETAL device. They're looking at putting, different types of thermal cameras on them themselves. So we're partnering with a lot of people in the United States to, have these sort of stand type solutions, ones that you're going to spend 5 seconds looking at. For instance, they're in badging systems. If they're an added security layer, for instance, they have facial recognition and they can be added to the badging system. Of course, corporate communication, I thought this was a great idea. You have people in, they're going to look at a screen for 5 seconds, bam, you got their face, you do the thermal check, and entrance tracking, employee tracking. So This is similar to those retail technologies. So if you work in an office building, you can see who came in and left at what time. And this is just data to give additional information to whatever access control system you currently have. So it's just another data source, how much your building is used, you know, who's coming in, what volume of people are using what entrance, et cetera, right? So once again, you know, this is only the start of the type of solutions that AOPEN and AOPEN's partners are going to be offering in the United States. One unique feature of our T-Guard software is that it does have face finding technology. Now, one of the biggest concerns when you install cameras at any system is security, of course. So this solution can be implemented as a completely closed local solution. It requires no outside internet connection, no cloud connection, no nothing, right? The other thing is that this is face finding technology. It's not facial recognition. It doesn't remember who you are, who you came from, doesn't care doesn't care about any of that. What it does care about is trying to accurately find your forehead, right? And so this is just a system that helps eliminate additional noise or background noise or environmental noise from your measurement, right? So how does it work? Well, the Heat Finder is a dual camera system, so it has a regular camera, 1080p, positioned about an inch above the thermal camera, right? And so the issue when you have dual camera systems is, of course, convergence, right? So if you imagine a line coming out of each lens, well, there's going to be they're going to intersect at some point, and that's the point where you want to be at, because if it finds your face, but you're a few feet left, you know, the thermal image isn't going to line up with the visual image, so it's not gonna give you a great measurement in that case. So the most important thing when you're dealing with dual camera systems is alignment or convergence, whatever you want to call it, right? So this software, this face finding technology is in the T-Guard software. And so the recommendation, if you do want to use this, is that you're probably going to want to run something a little bit beefier than an i5, especially if we want to find more than one face. And you got to have a head-on configuration, which means that you got to have people walking towards the camera, and then they're going to take a hard right. So if you're just doing thermal, of course, you can just have people walk straight by your desk or your entranceway or your door, whatever. But due to this alignment issue, or restriction for face finding technology, you got to have people walk straight on so they hit that area. The other thing in terms of thermal cameras is there is slight differences between the distances. So the most accurate systems are going to have measurement at the same plane. So like I said, with the Heat Finder technology, you want to be within 6 meters, but you want to make sure that if people walk by, that they're roughly the same distance away, because one of the key aspects of creating a stable measurement is basically a relative measurement, right? You can create the most accurate system in the world, super expensive. However, you can sometimes get that much accuracy from just calibrating a system correctly and then just doing a relative measurement offset. So this system allows for relative offset as well. How do you do that? Well, you plug in your camera in the morning, you set up your little check station, and you walk in front of it and you use a medical thermometer on yourself, and then you just put in a quick offset and you're good to go. And you make sure that people are roughly around that same distance as they walk by the camera. All right, so what do you get in the box? So now that we talked about the technology, the advantages, how it's used in the field, the interest in it. So what do you get in the box? So the camera is on the left. It has a typical micro USB on it. It comes with a USB power adapter. You can pretty much use any one. You can use your phone charger if it wants. It's pretty generic. The other thing in the box that's interesting is that it does come with a wall mount. So it comes with drywall screws and a wall mount in case you just want to put it up around sort of like an access point and things like that. So the other thing that of course, if you don't want to do a wall mount solution, is you're going to want some floor mount solution. So the floor mount solutions that I like for these type of setups is that, yeah, you can use any tripod, right? Any 6 to 7 foot 1/4" thread. A 1/4" is the standard, what's on the bottom of your SLR. So it works with any camera equipment, but I really like the small footprint because you have to get within 5 feet of these things. And if you have a tripod with like a 5-foot footprint, yeah, it's going to be stable, but that's going to limit your access range. So I found that, you know, you can buy these VR sensor holders for like $40. You get 2 of them on Amazon, or you can buy a nicer camera tripod. They have a really small footprint, so you can put them like in front of your desk, things like that. The awkward thing comes when you're implementing these devices at a front desk is, you know, what tripod do you use for like your actual desk? Because actual desk height is around 3 feet, but you want the camera to be at around 6 feet. So it needs to be like a 3-foot tripod. So, you know, it's usually better just to have the tripod either in front or to the side or something like that. The other thing to note about whenever you see these cameras implemented is that they're pointing down. And it's not because they can see your forehead better pointed down, it's because that there's less likely to be background noise. So if you point a camera straight across, and it's just pointed out a door, you're probably going to get the sun some time of day, right? So it's just a strategy to reduce background noise in the image. The other thing, of course, you need, as I mentioned, system specs are pretty low. All you need is a standard i5 generic. Just running the thermal scan only on one camera gets you around 40–50%. You add facial finding to that, you're going to get closer to 80. And if you want to do all entrances, then you're going to need a beefier system than that. So the T-Guard system can definitely handle multiple cameras similar to a typical IP DVR. All right, so let's talk about the software. I'm not going to go through the software in detail, but as I mentioned, Fusion is an on-camera config tool similar to other IP cameras. You just connect to it, download it, install a few libraries, and you set up the AP mode configuration. Always change the password, of course, et cetera, right? The T-Guard is where all the massive amount of configuration is. Everything from user control, all those offsets, thermal offset, calibration, user control, setting up all your alarms. In the Taiwan market, the alarm is typically set at 38, which is 106 degrees. So we've been asking them for all the typical numbers and what they do and the responses and things like that when they implement these systems. So those are the two primary pieces of technology. The firmware on the cable in terms of camera itself, in terms of stability, it's been around for a while, so there hasn't been a whole lot of firmware updates, but the T-Guard software, they are still improving. That's a piece of technology that the Acer Select team owns, so they've been working on making it better and better. So finally, to sum up today's solutions, I hope I'm on time. I haven't been watching. Oh, perfect. All right, here we go. So of course, we're talking about the product, the Heat Finder thermal imaging camera solution. The main points that we did is it needs to be a market leader for price. It's proven in the Taiwan market. It's made in Taiwan, developed by the Acer Select team. It's fast, multiple continuous measurements at the same time, very non-invasive. That's the main reason I liked it, because I hate standing in line. And of course, it comes with comprehensive software to get it rolling, right? So you can go with this solution, and then you can also consider, as our partners develop solutions with cameras and our e-tile line, those solutions will be available sometime this year as well too. So across the board. So I hope you, so this is the main point of the webinar today. Hope you learned a lot about thermal imaging, what's important, where to buy. So we just put the part numbers in with all our major US distributors. So that's going to be going out this week. So we should be able to take orders this week. Of course, for any sales inquiries or you want to know where to get this product from who, you want to know what partners are working on different types of solutions for this, talk to you about that too. If you're interested in making a product out of this camera and putting it with one of our e-tiles or some other system, of course, info at AOPEN. And finally, The last thing, of course, is that AOPEN, just in a general sense, what we're up to this year is just not only this product, but we're still very focused on, of course, our Chrome-based Mini technology. It's the #1 use case for this device turned out to be a supermarket application and restaurant application. You may have seen one at your local restaurant or your local supermarket, mostly as status and little menu boards and things like that. But they work great as little Hangouts and Google Meet sort of devices that you can put on your desk, and for all the kids that are staying at home with the remote learning. And of course, on the bottom, we're really focused this year on our really slim, ultra slim 4K media, completely solid state. We have a great line of these, especially if you're developing kiosk applications where you really want a device that's completely maintenance free. And AOPEN in general, yeah, we're just cross-platform. We want to make the most reliable devices, Windows 10, Linux, Chrome, and stay tuned because we're really hoping to finally get some quality Android devices on the market. We got a really cool 10-inch this year, and we're looking at releasing an entry-level box as well. So always, if you're interested in any of these products and any of those questions about Heat Finder, where to get it, info@aopen.com.